Hello, everyone. Good evening, and thank you for joining us again today. Hello, Katha. Hello. Lovely to have you join us again today. Today is day 2 of our masterclass on DevOps. Lovely. Hi, hello. So yeah, I'm going to allow you to unmute your mic and just tell me one or two things you learned from yesterday's session. So you can go ahead and mute your mic and speak if you want to. Anybody? Uh, I don't want to believe we did not take anything from all of what our facilitator shared with us yesterday. So what was that one thing that you learned or the one thing that stood out for you from the whole session? Why am I not getting a response? Am I safe? This is this is shocking. Muniri was here yesterday. I think I see a couple of people that were here during the class yesterday. So are you people telling me that there is not even just one thing that you took out from yesterday's session? And if you don't want to unmute, you can as well use the chat. Okay, I think I can take that. You can use the chat. Okay, Counter said, okay, thank you for today's session. Day one was very insightful. I really appreciate the clear instruction of DevOps concepts and practical approaches. All right, thank you very much for that, Kauthar. Any other person, you can as well use the chat box, right? Just drop one or two that stood out for you yesterday before we start today's session. We already have a facilitator on the call, so that we don't delay him. Oluwatosin said yesterday was great. The monitoring tools were on point, right? Thank you for that, Oluwatosin. Any other person? Meanwhile, we are quite few on the call. This is 3 minutes past 4. So we're going to give a couple more minutes for people to join us. And at exactly 8 minutes past 4, let's just give them like 5 extra minutes, right? So at 8 minutes past 4, we're going to kickstart today's session. We have our facilitator on the call already. Oluwatosin said, maybe I missed the point on how to get the source code. Please take our facilitator will probably touch on that again today. And when we start, I'm just going to probably ask him to start from there. So before we move into today's session, we start from where you missed and we get right into it. But then thank you so much for that feedback. Any other person, do you have anything you want to share with us? What is one thing that stood out for you? You can unmute yourself and you can also use the chat box to drop your message. What was that one thing that stood out from you from yesterday's session? Anybody? I want to believe that Okay, yesterday I realized that a couple of us are not actually DevOps professionals, but then I also want to believe that a couple more of us are DevOps professionals, and we learned something from, in fact, not just something, we learned a couple of stuff from yesterday's session. I am not a DevOps professional, but man, all the terminologies, the lingos, Pastor was in yesterday. I'm sure when I hear them somewhere else, I would, I might not be able to totally relate, but then I won't be entirely lost. So yeah, I need you guys to tell me one or two things you learned from yesterday's session. You can share with us. And if there's any other place you think you did not get, like Oluwatosin rightly mentioned, that she missed the point on how to get the source code, can as well let us know so we start from there today before we go right into today's session. Caldera says, I'm a master's student in computation biology, bioinformatics, and data analysis. I'm passionate about AI, healthcare research, and using technology to make a positive impact. A huge thank you. Oh, this is lovely. Thank you, Counselor. Counselor said, a huge thank you to the Women Textiles team for this masterclass. I'm really excited to learn and also very interested in the bootcamp and fellowship opportunities. Looking forward to connecting and agreeing with you. That's lovely. Mwah, mwah, mwah. Thank you so much. Thank you so much. This is what we enjoy when we are able to not just teach, but also give impact. Thank you so much. This is lovely. And also, we are looking forward to having you in our community. Like I mentioned yesterday, the bootcamp, a call for application for bootcamp is out. Please check our Instagram page and you will get to it. I would also try to see if I can get the link for the registration and drop in the chat box. But when I drop it in the chat box today, please remember that the boot camp is for ladies only, it's for women only. So for the brothers in the house that we just allowed for our masterclass, you cannot register for our boot camp. But you can share with your sisters, your cousins, your aunties, and any female figure in your community that you think will we will enjoy this opportunity for them, and it is free. All of our programs at Tech4Dev is free. Nobody is asking you to pay anything. You just come on board, register. Hopefully you get selected, and right, you get right into is take your courses for the first 2 weeks and use your last week for your project. So it's basically 3 weeks all together. Right. I'm enjoying Malachi because yesterday I see my Malachi and my facilitator were doing one-on-one, and I so much enjoyed it. It was lovely. It just showed how much you were into the session. Yeah, Malachi say yesterday class covered metric, logs, and trace. Yes, I know you mentioned all of this. I think I heard that yesterday. You also mentioned that Prometheus was used as a time series data for scraping the metrics, while Loki was log aggregator for capturing log. Thank you. Prompter was used to harvest all the logs, including the Docker logs, and send to Loki. Grafana was used for the visualization. Even if I don't know anything, I think this Grafana is something that I'm sticking to right now because we're just going back and forth with Grafana yesterday. All right, thank you so much for that. Culture says two things I took from day one. DevOps is about the collaboration and efficiency. Yes, yes, it is basically. Automation makes workflow more reliable. Yes, that way the developers would not just how do I put it? They don't have they don't have to wait till the problem becomes as much as like something they cannot handle. We have the DevOps people there that would probably working on that for them and test and all of that. Thank you so much for that. She said it was so impactful that I shared what I learned with my friends. Lovely, lovely. And I hope you share the link with your friends to join us for today's session because today is going to be more. Supplementary was used for traces. All right, thank you so much, Malachi. Our facilitator is already on the call. And okay, I said we're going to start at exactly 4:08, and this is 4:09. So I think we're just going to kickstart it, and every other person will join us along the way. Hello, Ajibola.
Yeah, good afternoon. Good afternoon,
Good afternoon.
everyone.
Good afternoon.
Yeah, it's nice having
Thank
me
you
here
so much for
today.
joining
I can see
us.
everybody saying they enjoyed yesterday's section.
Yes.
Hopefully they enjoy today's one also.
Hopefully, hopefully. Okay, but before we get right into today's session, someone mentioned that she missed he or she, I don't know, missed the point on how to get the source code. That was a mess of the session. So maybe you want to start from there.
Yeah, so the person is going to get the source code today because we'll be dealing with CI/CD and infrastructure as code, and we'll be making use of those source codes on a remote repository. So yeah, I would share the link on the chat when we are done.
All right. Thank you very much for that. So yeah, you have the floor. Please go ahead.
Okay, thank you. Thank you, everyone. So today I promise that it is going to be a transformative journey into the world of DevOps automation. My name is Adedamola Ajibola, and we are going to unlock what I call automation superpower. So let me get my slide. Hmm. Yes. So today's topic is automation as a superpower, building your CI/CD pipeline and infrastructure as code workflow. Mm. The section for today is for us to automate to eliminate manual errors, reduce development timeline, make infrastructure reproducible and consistent, and empower DevOps through CI/CD and IaC. So before we dive into what is CI/CD and how it is, I in this next 1 hour, 40 minutes, you will not only understand the theory behind modern DevOps practice, but you will also witness firsthand how to build production-ready CI/CD pipelines that we can deploy both infrastructure and application automatically. So instead of us doing it manually, because when you deploy your application or you run your infrastructure manually, you are prone to error, and this process is going to eliminate all the error prones and everything. And then when we use CI/CD and infrastructure as code, we have automated process, scalable workflows, and that will fundamentally change how you think about software delivery. So let's dive into it. Yes, but before we get to what is CI/CD, I want to talk a little bit about the foundation of DevOps itself. What is DevOps really? DevOps is let's start with the fundamentals, and DevOps is just a buzzword, but it is a cultural and technical revolution that has transformed how we build and deliver softwares. Um, Developers will write code and throw it all over the world to operations team. I said yesterday that DevOps is the break it down, is it between development and operations. And now when you have your developers write code and they throw it to the world, to the operation team. Operation teams will struggle with deployment. They often have no idea how this application works or how they really works. And this will create like a slow deployment cycle. It will take weeks or months before your application is being deployed. Then when there's like breaking changes, there are finger pointing to what breaks when the team breaks on in your applications, and then we most often have like inconsistent environments. And when things are done manually, we are we are prone to errors basically, and that's where DevOps come into place. DevOps breaks down these silos by combining the development part of software and the operation part of software into a unified approach. And they focused on collaboration, where we have shared responsibility for the whole entire application life cycles. And we have automation, where it reduces manual workload and human error. There's no need for us having Bola to deploy those applications in the midnight or anytime a developer make change manually. We have like a CI/CD pipeline in our remote repository. Once Yemi, as a developer, makes his push to GitHub, there's a CI/CD pipeline already in place that is going to make that software delivery smooth and easy straight to the end users. And we have continuous improvements where we have fast feedback loops and iteration from everybody. And there's also monitoring, like as we discussed yesterday, understanding the system behavior in real time. So that's just like the main fundamental of the code. And if you think about DevOps, DevOps is like a continuous loops, and we have key phases to DevOps. We have plan, code, build, tests, release, and deploy. We also have operate and monitoring. So what is plan? Plan is when you define requirements and you plan the work of your software delivery. And what do we know as code? Code is what we have in this remote repository right now, where we write and we review our application codes. And build is when we combine and package the whole application. Test, in this diagram, we can see in this diagram, we can see where we have the code in the repository that we just move away from right now, and then make a commit. There's a CI/CD pipeline that is going to build and test our code. It's like automated testing at a multiple level where you test various aspects of your software delivery. We have release where you prepare for deployment. You want to deploy your production to different environments that you have in place. If it's development, staging, or you have a production environment. And we have deploy where we push your application to a production environment or a development environment or a staging environment. Because in a software lifecycle, we have different environments whereby when we have a developer build this code, you push it to a development stage where you have your QA, you have almost everybody to run tests and see that, okay, yes, is this application suitable to be pushed to the public? What will the end user see this application like? So before it gets to the end user, internally, we have QA teams, we have our developers, we have the DevOps teams, you have the database, you have the whole collaboration, the whole entire team testing those applications end to end to see that, okay, yes, this is ready to be pushed to the public. That's where we have the production environment. So production environment is like the environment whereby those products in that environment are the ones pushed to the public. They are good to go. And then we have monitoring where we gather feedbacks, metrics, and we monitor, we set alerting, just like as we did yesterday. Yeah, just as we did yesterday. So we have key principles for DevOps, and in these key principles, automation comes first. If you do something more than twice, you automate it. And this isn't just about efficiency, it's about constant consistency and reliability, because as a DevOps engineer, you don't do things manually. And if you have been given a task and you see that you go back like twice or three times doing the same thing over and over again, the best thing as a DevOps engineer is to create like an automation, either a bash script or a CI/CD pipeline to automate that process, so that you won't go back there and do it manually, or the next person that is not available, the next person that is going to come and jump on that project won't do things manually. You already have a documentation where you document the steps that is being taken. So what the engineer needs to do is just go to the documentation and see how the application is being managed or is being done, because you might not work for a company all your entire life, at some point in time, you will definitely switch, or you might want to switch, and you might also stay in that company all through your life if you enjoy what the product that you're building over there. We also have infrastructure as code. That's where you define that infrastructure as code is just your infrastructure that should be defined in code, and that's where Terraform comes in. I don't know if you've heard about Terraform. There are different types of infrastructure as code, but the most popular one is Terraform. We have Pelumi and the rest, but the most popular one is Terraform. That's what we call infrastructure as code, where you write all your codes that you want to use to build your application, that you want your application to sit on. And yes, you push your code to a repository, just as we have this folder here called Terraform. You push your code to a repository, version controlled, and you deploy like any other application components. Then after infrastructure as code, we have continuous integration and continuous delivery. So continuous integration is what we call CI/CD pipeline, and this is what we have right here in GitHub. So in GitHub, to create your CI/CD, you need to create a folder called .github and workflow. So and you create like a YAML file for it. So we have continuous integration where you merge your code frequently. We have continuous delivery where you all continuous delivery is always ready to deploy to whichever environment you want. And then we have continuous deployments where you automatically deploy when it passes a test. And we have continuous monitoring. You always know what happens. Just as I said yesterday, when you monitor your application, you set alerts, and when there are issues, you are being alerted. And to build a system that detects problems quickly, you need and provide rapid feedback for correction. That's what we call them fail fast and learn faster. Because in all of this, to build a perfect system, you need to fail fast, and that's where you have the development stage where you test, where you fail, you test, and you learn on what to do next to make your application better. Yes. Now we'll go right into CI/CD, understanding what CI/CD is, because CI/CD is like the heart of automation. And what problem does CI/CD solve? Before continuous integration was painful basically. Team will work in isolation for weeks, then they try to make their changes, and then this lead to almost like integration error. There will be conflicts in broken build, there will be delays in releases, in pushing software delivery to the public. But once you have a CI/CD in place, and you have it in your remote repository, you are you are good to go. You have frequent commits, you have automated builds, and you have comprehensive testing where you have unit testing, integration testing, and like code quality checks, and you also have fast feedback. So because that fast feedback means when your developer knows that within minutes, if there are changes broken in something, it's going to fix it, and we push our code, and everything is good to go in no time. So this is how a CI/CD pipeline should look like in this diagram that we have right here. And then there are various tools for CI/CD pipeline. We have GitHub Actions. So GitHub Actions is a tool by GitHub. GitHub is a remote repository where you store your codes. There are various
Hi,
remote
Ajibola.
repositories. Yes.
Sorry for interrupting. If you are sharing your slide, we cannot see it.
Oh, are you saying you can't see my screen all along?
We can only see you. We cannot see your slides at all. We can't
Oh,
see your the screen you're sharing.
Jesus, you should have said that earlier. I thought I was sharing my screen and everyone is looking at it. I'm sorry for that. Can
Yeah,
you see
that's
my
fine. We
screen
can see.
now?
Yes, we can.
Okay. Good, 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 good. Okay. So this is how a CI/CD should look like in this slide and in this diagram. And if you have any question, you can drop it on the chat just like how we did yesterday, and I would answer along the line, and that will make it more interactive because I know a lot of you have a lot of questions to ask. Yeah. Can I go ahead?
Yes, you can.
Good. Good. Thank you. Thank you. So in the CI/CD pipeline, you need to have like a build, a unit test, an integration test, then you review. Is either you want to deploy to staging or you want to deploy to production. And there are various tools we can make use of for CI/CD. We have GitHub Actions. We have Jenkins. Jenkins is like a old CI/CD that has been in place. It's one of the oldest, and most enterprise companies make use of Jenkins. We also have GitLab, but the most common one that we know is GitHub Actions. You can check them out. GitHub Actions is a tool that is being published by GitHub. GitHub is like a remote repository where you store your code and where you compile and have everything in it. So, and their CI/CD tool is called GitHub Actions. It's called GitHub Actions. So you can check it out and you can check their documentation out. We have different tools. Even AWS also have their own CI/CD pipeline. GCP, that's Google Cloud, they have their own CI/CD pipeline. Azure has their own CI/CD pipeline called Azure DevOps. So whichever ones that align with the organization you are working is the one you make use of. If you're in an organization where they use Azure, then you most definitely are going to use Azure DevOps as Azure pipeline as your CI/CD pipeline. Mhm. Mhm. Yes. So what's the difference between continuous delivery and continuous deployment? Continuous delivery, in every changes that you pass your automated tests, this can be deployed to production, but it requires like a human approval, and you maintain the ability to deploy at any time with confidence. And for deployment, every changes that passes your automated tests when you test your application automatically deploy to productions, and this require like a robust testing and monitoring, and that's been done in your development or staging environments. And I think I've mentioned different tools for CI/CD pipeline that you can use for your CI/CD pipeline. Yeah. And AWS one is called Azure, sorry, code pipeline. Yes, AWS code pipeline. And then the old CI/CD pipeline that we have Jenkins, we have Circle CI. Those are like the two ones I can remember. But for today, we are going to be making use of GitHub Actions to be precise. And why are we using GitHub Actions? Because my code repository for my demo for today is in GitHub, and it's best that we use GitHub Actions because it's going to make it very direct, and it integrates direct to the repository. There's no separate infrastructure to manage, and it has like a reusable workflow for us to use, and there's also excellent documentation and community support from GitHub. That's why I asked you to, if you're a beginner or you don't know anything about GitHub Actions, I will encourage you to check their documentation and then go on YouTube and watch a lot of video on how to use CI/CD pipeline. And basically, first approach should be reading the documentation, and then you go ahead and watch few YouTube videos to cement your knowledge on it. Yeah. So, what is I think I'm done with explaining CI/CD. We can go ahead and talk about infrastructure as code a little bit before jumping into the hands-on. So, what problem does infrastructure as code solves? So in the traditional way or traditional infrastructure management before the introduction of infrastructure as code, you can just try and imagine trying to recreate your environment in the old world. And in the old world, that's like you going into your AWS environment, clicking through your cloud console to create infrastructures. And that can lead to a long and error-prone way of doing things, and also documentation is going to be way error-prone because you might not be in that organization for life, and when someone else comes in and wants to read your documentation, is he or she is going to find it so hard to go into the console and see what you've created. But if you have your infrastructure as code being consolidated into a repository, you write your code and you push it to your remote repository with a lot of documentation. Any new engineers coming in can go in there, read the documentations, read your line of code, and understand what infrastructure has been built in various cloud resources or cloud various cloud infrastructure that you have implemented. So yeah, we have different type of approach to infrastructure as code. We have the declarative, and we also have the imperative way. So declarative is like you creating imperative is like you creating a server, then you install maybe like an Nginx, and then you configure it. But declarative is like, I want a server running Nginx with this configuration. And declarative approach is more reliable because they describe the desire and states, not the steps to go through, just like what we have here in our Terraform code. In our Terraform code, this is like a declarative kind of way to run your Terraform code. You tell them what you tell Terraform, you write it on your Terraform code. This is what you desire, and this is what you want. You state it there, and with just few clicks, is being created on different cloud platforms, and it's being pushed to a version control system. So what we mean by version control is GitHub, a remote repository where you push your code to. If you want to if your infrastructure definition, if you want to make changes to your application code, or you want to track what has been done to your infrastructure, or what changes have been made recently to your infrastructure, you come to GitHub and you track those changes. And there's also ability for you to roll back your infrastructure changes. And there's collaboration through pull requests. If you have various developer working on project or working on your infrastructure, all what the developer needs to do. For example, I Adedamola and Adebola, we are working on building an infrastructure for a particular, for Tech4Dev, for an example, and we are both working on that infrastructure, and we are in separate places. All what Adebola needs to do is just to pull my code and make changes to whatever change and whatever, either she's making the changes or she's adding to the infrastructure. Then she create a pull request and then tag me for me to review, and then I merge my requests. I merge that pull request, and voila, we have created that infrastructure. And also an advantage for using declarative approach is also consistent environments across team, either in your dev, your prod, and your staging environments. It also gives like an immutable infrastructure. So instead of you updating your servers in place, creating new servers with updated configs, this approach of declarative way eliminates configurational drift, and also gives us the ability to roll back very simple. And then why are we using Terraform? Basically, Terraform is multi-cloud, so you can check them out and also get to read their documentation. This is Terraform. It's most widely used by most companies. There are different infrastructure as code. We have Pulumi, we have a lot. We have AWS have their own infrastructure as code. They call it CloudFormation. GCP also has their own, and Azure also have their own. But Terraform here is multi-cloud. It works with AWS, it works with Azure, it works with GCP and different cloud provider. And it has like an extensive provider support and communities where you can go ahead. We have a lot of modules that is already being built by different softwares engineers. All you need to do is just pick the module you want to use, and you deploy it with a simple command. And it's easy for you to track what has been deployed. And Terraform also has this I'm looking for the word to use. They have this feature where you can plan before you apply. So you can plan what you want to deploy, or the infrastructure you want to build on your cloud resources, and you see exactly what changes is being made, or what infrastructure you want to build. And the workflow is pretty simple. All you need to do is just there are different steps to this Terraform workflow. You write your infrastructure inside the TF file, because if you look at this repository here, you can see that everything is in .tf. The TF at the end of it is called Terraform. So you write everything in .tf, and if you look at my CI/CD workflow for automatically building my Terraform pipeline, you can see that the first step is for you to initialize your Terraform plugins. So Terraform init is like a command where you run, and it downloads all your provider plugins, and provider plugins is what we have here, is what has been defined here. So I want to deploy my applications to AWS, create like an S3 bucket for me. And I've written all what I want to do, build this application in a US list one environment that's somewhere in America. Build it for me. And you can also pick anywhere, because in AWS we have different region. We have We have different regions, so it depends on whichever company you are working for. But the closest to us in Nigeria here is London or Ireland. So you can pick anywhere you want to deploy to, either Frankfurt, Japan, India, anywhere, or you want to pick US. So you can do that. And in my line of code, the next step, the next step we have is the next step we have is to validate that code to see if there's an error. And if there's an error, it's going to tell us there's an error, and then we make changes to it, and then it's planned for the next step after validating is to preview changes before applying, see what is meant to be deployed into AWS, and if you are cool with what it gives you, you go ahead and apply or create or update your infrastructure. And we also have Terraform Destroy. Terraform Destroy is like the delicate part for Terraform because it's clean up your resources. That means the resources you want to deploy to the cloud, either AWS, Azure, or GCP, you no longer need them anymore. You just want to destroy them, and you don't need that infrastructure anymore. You want to go ahead and build something else. So that's what Terraform destroy means. So we go right into it, and you see how CI/CD and infrastructure as code work together to create like a true automation superpower. Yeah, let's see how it works. So I have my I have my virtual studio code here, and all I have to do is just to write something. Mm. I'll just delete something. Mm. And then oh, I make my push. I didn't talk about, or I can also discuss it here. I didn't talk about I only talk about the infrastructure as code. I didn't talk about the CI/CD to be precise. So today, let me use this. What my Terraform code is going to be doing is basically deploying to AWS. So this is like an architectural diagram to what we'll be deploying. And I will explain this to you. So in AWS, this is what we call AWS, Amazon Cloud. This is what we call AWS, and we are going to be building an infrastructure on AWS. So the core component of what we are going to be building on AWS cloud is like I explained yesterday, we have our front end and we have our back end, we have database, and our CI/CD pipeline is basically GitHub Actions and Terraform. So the front end is like a React Native application hosted in a Docker container deployed to ECS, Fargate. And our backend is also a Java Spring Boot application hosted in a Docker container deployed to ECS, also Fargate. And our database is we are going to make use of RDS on AWS. So that's just it. And this is the cloud architectural diagram of what we are going to be looking at basically. And this is we'll be deploying on ECS. Why ECS? Why are we using ECS? Why did I choose ECS? So because the application is being containerized, right? And we want to try something simple on the cloud. ECS is what comes to my mind. ECS, and we are going to make use of like the serverless container orchestration. ECS is almost similar to Kubernetes. So, but I choose ECS because it's on the cloud and it's going to be simple. And it's not going to waste much of our time. Like me creating a Kubernetes cluster is going to take a lot of time because Kubernetes is broad. And then, but ECS in a few clicks we are done. So ECS is like a serverless container orchestration and with managed infrastructure, and it reduces the need to manage our EC2 instance. And so the front end and back end are going to be hosted in two separate ECS service for independent scaling. And both services are both deployed on Fargate. And we are going to, if you can check the diagram, you can see that our applications, we have our application is going to be deployed in a private subnet away from the public because your public subnet is where a lot of people can have access to. And in a real world production settings, you are going to deploy your web application in a private subnet. This is a three-tier architecture where we have public subnet, your private subnet for your application, and you also have a private subnet for your database, with each subnet having their separate security groups in case you have a hack. You know, when a company has a hack, someone hack into their application or into their system, you can easily detach your security groups. You can separate your database from your application so that you'll be able to troubleshoot and see where the issue is coming from. And in this application, we also have auto scaling. We are going to configure our ECS tasks based on CPU and memory utilization. I think I explained that yesterday in our monitoring. So all of these things are being visualized in the diagram. We have our database, which is in a third tier. So database is like MySQL basically is what I'm using here because in our demo for yesterday, I made use of MySQL for our Docker Compose, and I'm still making use of MySQL in this Amazon RDS. Why did I choose MySQL? It's chosen for its performance and flexibility, and is also widely adopted, and is also on an open source environment, basically. And the reason why I chose RDS is basically because the managed database features in AWS, it includes automatic backup, snapshots, and it scales. And you have like a multiple availability zone failover for high availability because in DevOps, after scalability, reliability, you also need high availability also, and it's been deployed in a private subnet for enhanced security. Because if you are deploying your application in a production environment, you need to emphasize more on security. You don't want anybody to have access to your application or come in and hack your application and start demanding for ransom, demanding for money. So in our public subnet, we have application load balancer. I'm sure everybody here knows about application load balancer. The purpose for using application load balancer is because it routes external traffic and securely to our ECS, to one we have in a private subnet. That's to the front end and to the back end. And it also has like SSL and TSL integration using internal AWS certificate manager for HTTPS to make your application well secured. So imagine you type in www.techdev.com. Let me give an example. www.tech4dev. So the reason why we can come here and click on techdev.com is basically because the application is secured. Nobody can, and it has like a certificate that is valid. So That's why we are making use of ACM here in our deployment to make our website or our domain name that we've chosen to be secured, and it also has like a certificate for it. So on AWS we have a AWS certificate manager. It works hand in hand with Route 53 to secure your domain. We have IAM also. We have IAM is basically a granular role for ECS, RDS, and Terraform deployment is going to help us to ensure that at least the principle of least privilege is being enforced in our application. If you come here, I will share the repo and you go through it. If you come here, you can see that we have like a Terraform code defined for IAM for the ECS that we are making use of. We have Amazon VPC. Amazon VPC is a custom VPC that is provisioned. This is it here. This line we have here is what we call Amazon VPC. Is a custom VPC that is provisioned to host application infrastructure, ensuring isolation from other resources, and its components consist of public subnet, just as I've mentioned earlier on, where we have our load balancer, NAT gateway, then we have our public subnets, where we have our ECS stacks for front end and back end. And we also have our RDS instance. We have our NAT gateway. What's NAT gateway? NAT gateway provides internet access for public subnets basically. And we have our internet gateway. Internet gateway enables internet access for public-facing resources, just like the application load balancer that is in our public subnet. We also have route tables. So what route table does is to route traffic appropriately between subnets and gateways. So it depends on how you route your route table. Everything is being defined in the Terraform code. And we have Route 53. Even though Route 53 is not in this diagram, what Route 53 does is just to simplify domain management and route traffic to different domain name. I can show you Route 53 here on AWS console. So this is Route 53. You can come here and then you can check the documentation for Route 53. You can buy different domains. So I think we have Simeon Olabode on the call. If Simeon wants to buy a domain for himself and he wants to call it simeonolabode.com, he can just come here and buy a domain name. See, Simeon. Come here and buy a domain name. So we can see that simeonolabode.com is available. All he needs to do is just to pay this amount of money, and this domain name will be available for him, basically. So that is it about this diagram, and let's dive into it straight up. If there are any questions, you can just ask, and I'll answer it along the line. So what this pipeline is doing is basically to deploy to Amazon ECS, just as I just showed you in the architectural diagram. This workflow is once my Terraform pipeline is being built completely, it goes ahead and take the it goes ahead and move to my ECS deployment pipeline to deploy, and it's being deployed on this branch. That's develop branch. This is develop branch, yeah. So on this branch, we have a master branch where this master branch is like what we call production branch in an organization settings, whereby after you are done testing on your development branch and you see that everything is working, you create a pull request and you merge your code to production for you to deploy to your production environment. So that's what we call development branch. But for today, we'll be making use of development branch for our hands-on. Yeah. So this is just to check for my credentials that I have configured on GitHub, that I have saved as secret. And this basically this basically log into Amazon ECR. That's the In Amazon, they have like in Docker, we have Docker Hub where we store our images. In Amazon, we have what we call Amazon ECR. That's where we store images. So what this deployment is doing is logging into Amazon ECR, build and tag my image, and then push my Docker image. After pushing my Docker image, update my ECS tags definition with this new image, and then deploy to front-end services that we have. So after this class, you can all go ahead and Google about ECS and learn about how it works, the services, tags definition, and the rest. And then this also apply to back end. Basically, the same steps we have for front end is what we have for back end. If you check this code, when I share the repo, you can see the name of it, deploy front end to ECS stacks. So the same process also apply to the back end environment. So all I have to do is just to push my code. I'm going to give it app commit and push my code straight up. So we come here and we click on actions. So right now, action is showing us that our Terraform pipeline is building automatically. So instead of me doing it manually on my Virtual Studio Code, um, GitHub Action is doing it for me. I think it's done. So after building, it goes ahead and automatically deploys our front end and back end to AWS. Once this deployment is done, I would go ahead and go to the console and show you the services that is being deployed.
So we have a couple of questions in the chat. Can we take them now or we'll take them later?
Yes, we can take them now. We can take them while we have our CI/CD building up.
Okay. Oluwatosin says, when and where does security comes into DevOps?
So technically, security comes into DevOps at every stage or any stage of DevOps. In your pipeline, you can integrate security, and that's what we call DevSecOps, basically. So for now, for example, we have for this masterclass, we are making use of Docker. What we can do is to get maybe Docker Scout or tools that can scan our images for vulnerabilities and the rest. So it depends on what security part you want to test, basically. So if you have your security tools, I didn't put that in this tutorial because it's going to make the section long. It's a different topic on its own, DevSecOps. So we can just add that to your infrastructure level or your application level, whereby it tests. There are different workflows for that. We can check GitHub Actions. There are pre-built installation where it scans your Terraform code for securities or for vulnerabilities and tell you what to do. So you will set that on your CI/CD pipeline. If it does not pass this following stage, don't deploy the application. Same as your application too, or don't deploy the infrastructure. Same as your application too. Once it scans for a typical Docker image and the vulnerability that we have is kind of high, or is scanned through the repo and it sees that a developer makes a push or makes an environmental variable push to the repo, it's going to flag the deployment and alert you. And you can also make this deployment that you can send it to your email, send to your send to your Slack, send to your teams that, okay, deployment has been made. If a deployment fails, the reason why it fails, maybe because there's a vulnerability, there is a high critical vulnerabilities, and you need the developers to fix that. So that's where security comes in place in your CI/CD pipeline, and we call that DevSecOps. It scans for vulnerability at different stage, and if it does not passes, your deployment gets failed. But that is not implemented in this tutorial. This is just like a simple deployment to AWS and to ECR. So you can go ahead and check that out for tools that you can implement for security in your DevOps pipeline
All right,
and
thank you for that.
infrastructure. Yeah.
Okay, great. The next question is, okay. Yes, the session is recorded and the link will be shared with you. Someone says, Git this. I'm not sure I get what the question is. Or the second question is, will the CI/CD fail when the test fails?
Yeah, so you can configure your CI/CD pipeline to fail when the test fail, because in your test you have like a tool where you've written down that, okay, pass this pipeline if there is a low critical vulnerability, fail this pipeline when the vulnerability that is being scanned is way higher than the normal. So your pipeline is going to fail if it does not pass that security check. And you can also automate it to send you an alert to your mail, to your teams, so that developers that is working on that project can fix those vulnerability and make a code change or a code push to the repo and just CI/CD run over again. If it's successful, yes, it passed that check. It moves to the next stage of your CI/CD pipeline.
Okay, great. So the next question is, why do most DevOps prefer AWS for their pipeline?
Yes, for their pipeline, no. Now, AWS is a cloud platform on its own. So, and for pipeline, pipeline is what we call CI/CD pipeline, continuous integration and continuous development. So, if you can see from my slide here, continuous development and continuous integration is a tool on its own, and we have different type of tools for it. We have GitHub Actions, we have Jenkins, we have GitLab, we have AWS pipeline is what we call AWS code pipeline. AWS code pipeline. And the main reason why you don't see DevOps engineer make use of AWS code pipeline is because if your organization is making use of AWS, you can make use of AWS code pipeline. It's limited to AWS alone. Same way GCP has their own pipeline, limited to their cloud platform alone. Same way Azure have their own Azure pipeline, DevOps or Azure DevOps, limited to their cloud platform alone. But if you want something that is diverse and you can make use of, you can integrate it with different cloud platform, you can pick GitHub Actions, especially if your organization makes use of GitHub for their remote repository. So you can pick GitHub Actions. GitHub Actions integrates well with AWS, Azure, GCP, same as Jenkins, same as GitLab, same as Circle CI. So you can check them out. GitHub Circle CI, Circle CI, Circle CI. Circle CI is another CI/CD pipeline that you can make use of. It's also flexible. You can integrate it with different cloud platform, so you can check their documentation out. It's one of the old traditional CI/CD pipeline, same as Jenkins. Same as Jenkins. This is one of the oldest. Any enterprise organization you are working with, they most definitely makes use of Jenkins. So yeah. But any new organization, any new startup, they can you can see them using GitHub Actions because they make use of GitHub as their remote repository. We also have GitLab, GitLab CI. We also have GitLab CI. So GitLab is also a remote repository, and their CI/CD pipeline is called GitLab CI. So you can pick whichever one that aligns with your project or what you want to do. But the most flexible ones that integrate with different cloud platform is GitHub Actions, Jenkins, Circle CI, and the rest. So each cloud platform have their own separate pipeline. So we can check them out here. Code pipe, code pipeline. So you can see it straight up. You can see it straight up. So this is an AWS integrated code pipeline, and it can only be used on AWS alone. You can't say you want to deploy an application to Azure and make use of code pipeline. It's not going to work. Is well suited for AWS. Same as we have CloudFormation, Cloud for CloudFormation. So CloudFormation is like a IaC for AWS. It is integrated for AWS alone. You can't say you want to use CloudFormation for GCP or for Azure, but you can use Terraform. You can use Terraform for AWS. You can even see it from that documentation here. Get started with AWS, Azure, Google Cloud, Oracle, Docker, and the rest. You can use CloudFormation for Azure, for GCP, for Oracle Cloud, for Alibaba. You can't use that. So that's why we are choosing and we are making use of the flexible ones that we can use for different platforms. And then that is GitHub Action.
All right, thank you.
Did I answer that?
Yeah, I think you did. So to the last question here, since the resources may only need to be provisional once, except when scaling is required, is it correct to conclude that Terraform configuration might only need to be applied once during the entire project lifecycle?
No. So Terraform configuration can be applied at any point in time because changes might be made to your infrastructure all you need to do is to make those changes, push your code, and then automatically it builds. So at any point in time, an organization, or you might want to scale, and you might also want to add a little bit of features to your infrastructure. You might want to add monitoring or anything you want to add. All you need to do is just to write your Terraform code, push your changes to GitHub or any version control you have, and it applies immediately. It adds to your current infrastructure. So that is why Terraform is reusable. You can make use of it. You can also make use of it in a different environment also. But that is done. And for you to reuse it and make use of it in different environments, you need to convert this Terraform code that I have here into modules. So modules makes it make sense and makes it reusable for you to deploy to different environments, either staging, dev, or prod. Did I answer that? Is the person is he or she satisfied with the answer?
Yes, you answered, and person is
Yeah.
satisfied. Thank you. So
Thank
you
you.
can go
Yeah.
on.
Yeah. So now that we have our application being deployed to ECS, so Elastic Container Registry is where we have our images. So now nobody can go in here. Azure cannot come in here and say they want to make use of this repository because it's private just only to AWS. But we can go to Docker Hub where we pull those images we have. We can go to Docker Hub because any any developer, any DevOps engineer, any organization can push their images to here to this place. I think I have all you need to do is just to sign up and push your images to it, make it private and make use of it. It's flexible. It works with different platform. But AWS, for instance, where we have Elastic Container Registry, it works only with AWS. You can't use it for any other platform, just AWS alone. So this is where we push our images to, and this is the services. This is the service that we are making use of, Elastic Container Registry. I think I've explained it earlier on. A cluster, you need to check Google about it. What is a cluster, task definition, and the rest. So this task definition is where we have the backend and DevOps stacks running. Yeah. So as you can see, we have our targets, and that's a long time. I don't know. Backend is not running, so we need to check what's wrong. What's wrong? What's wrong? Why is it not running? So log is like the best way to troubleshoot whatever issues that we have. Still in progress. It's coming on. So in this code of us, we have monitoring, we have everything in place. We also have scalability. If there's huge traffic in the Terraform code, I've set a configuration whereby it scales up and it also scales down when it's at a particular threshold. So we have auto scaling in place for it. That makes it interesting. So when there's huge traffic, your front end or your back end application scales up and it scales down for cost, because on the cloud you need to be conscious of cost, because cloud is very expensive. You don't want the organization to run back to you that they are paying a lot of money when you can implement auto scaling and reduce costs, take away services that you don't need. Okay, I think we have our backend service running now. This is also monitoring. So it's monitoring the application. Once it hit a particular threshold, it scales up. Okay, we have our still in progress. So where's my code? Where's my code? Now 53. Not working. So we have our application running right now on AWS, and it's well secured. So this is like a proper production environment. And then this is being done without any manual deployment. And then my advice is that most times you can, before I try to automate whatever I try to automate, I came into this console and then create everything that I needed manually. So that gives me like a virtual representation of what I want to do automatically. Then I go ahead and write my Terraform code to provision all of this well secured. Thank you. So I think with this, I also want to add like best practices and professional tips, maybe in anything you want to do as a beginner, because I know there are beginners here and there are also advanced professionals. You can just begin or try something. You can just try a simple application and a basic pipeline, and then you try with that first before moving into complexity. And then when you try little, that gives you confidence to go ahead and then move ahead to complexity. And then don't be scared in anything you do at first. You is going to fail, because if you come ahead here and if you check my GitHub actions, you will see that I have resources that are filled. All I had to do was to check the logs and make changes to it. So you might not have a perfect pipeline at the beginning. All you need to do is to check your logs and see where the error is coming from, work on it and make changes to it. And then in everything you do, make sure that you make sure that you log everything so that you will be able, just like as we discussed yesterday, monitoring and logging is very important. You log everything you're doing, every application, infrastructure, and then you monitor like key metrics, set up alerts for pipeline failure. Like I said earlier, you can also put alerts into your pipeline that is going to alert you, because at the back of your mind, you can have it that, okay, yes, I have this belief that this pipeline is going to work, and you let it or you leave it and let it slide. Then your team lead or your product manager get back to you that, okay, the feature that we added has not deployed. Then you come back manually and see that, oh, your pipeline has failed. But if you have like an alert being set up that is going to alert you that, okay, this deployment failed, you can go right into it and you check and see what is wrong. Yeah. And you CI/CD is put in different places. There's what we call GitOps. That's a different topic on its own. So I'm just adding that here so that also GitHub also manages infrastructure and application through Git workflows. You can also check the tools out. One of them is Agro CD. It's a very nice one. It's like a declarative GitHub for CD. You can check them out also. Yeah. And in everything you do, continuous growth. So even me, I'm not perfect. I'm still learning. I tend to upskill myself every time and join communities, conferences, meetups, open source contributions, hands-on practice and personal projects. So learn to build small every day. Then you increase your knowledge, you try new things out, and then you can start with one tool, master it before you move to another. So understand both the development and the operation perspective of things. And if you are working for an organization, you focus on business outcomes, not just technical features alone. And also need to develop soft skills for cross-functional collaboration because DevOps is key on collaboration. You are not going to work on a project alone. You have different teams working with you. You have like the SREs, you have the project manager, you have the QA, you have the data guys, you have the DB guys. So you have the networking team, you have the cybersecurity team, you have the compliance and governance team. Everybody needs to work hand in hand so that there is collaboration and we all have a end goal of pushing a good product to the public for them to use. Thank you. I don't know if there's any question. Can anyone hear me? No, so you don't need software development if you are starting as a beginner, but I would advise you learn Python basically for a beginner for because mostly at some point in time for automation you are going to make use of Python or Bash scripting to automate most of your things. And it's also good for you to have the general knowledge of software development, software lifecycle. If you have a fundamental and basic knowledge of how software development work and so software lifecycle works, you are good to go. The only thing you need to learn for DevOps is to learn tools because DevOps is all about tools, different tools. You can work in an organization today, they make use of a particular tool, and then when you are moving to a new organization, they are using the different tools. So, yes, software is all about, DevOps is all about tools, but you need to have like a software development and operation knowledge. So, for a beginner, you can start with software delivery lifecycle and also pick up a programming language. And you can go to Google and Google roadmap to DevOps. You will definitely see that you need to learn a basic programming language like Python. So that gives you knowledge of how it works and how an application is being developed. Any other question?
And there is no question in the chat. But
Okay.
so if you want to ask question, you can just raise your hand and I would allow you to speak. Looks like we don't have any question.
Okay. I'm sure everybody understands.
I want to believe everybody understands since we don't have any question.
Thank you for having me today.
All right, thank you so much, Ajibola, and thank you for the practical session, the step-by-step. I'm sure the participants today were able to follow and grab one on. So thank you so much for the knowledge you've shared with us and for your time, because it's a Saturday evening. I'm sure most people want to be outside.
Most definitely. I'm sure
Thank you so much.
also. Yeah, you're welcome. Pleasure's mine.
Yeah. And to every other person on the call, this is the end of our 2-day masterclass on DevOps. And I am sure, I was going to say I hope, but I'm sure we have all been able to learn from our instructor for the past 2 days. We had a first session yesterday on monitoring and observability, and today we had pipeline workflow. And today was like a practical session or a step-to-step on how to get it. And also, I heard when he was giving advices on how you should always practice more, join communities, go for sessions on this on DevOps, and that's where you can always learn more. He mentioned himself that even himself is still upskilling, which would also preach at Tech4Dev, always upskill. Yeah, the world is changing. What you know yesterday, right? It's still there, but then there's probably a tweak to it. It's just like all of the apps used on our phone. I'm sure if you are using in fact, even WhatsApp itself is like every 2 market days like this, they have one new update or the other, which means life is moving. Or as a person, you also need to upskill. Okay. So I'm just going to, for those that didn't hear me or they joined late yesterday, I gave a brief of what we do at Tech4Dev, women testers under Tech4Dev. So normally this masterclass would usually be women testers masterclass, where we would have only ladies join the call. But moving forward, we're going to be having both female and male for the masterclass. So it's just going to be Tech4Dev masterclass and not only women testers only. But then, all that women testers, we have our bootcamp code 4.1 application out now. I mentioned earlier I was going to try to get the link so you can register. Give me a minute to get that. So you can share that with your community members, with women in your area. Basically, purely for women. Okay, it's purely for women. We have 6 learning tracks now. We have product management, product design, cybersecurity, data analysis, software development, and our new learning track is technical project management. Right, so you can go to our Instagram at Tech4Dev and check the bio. The link is there. I would also share it in the chat now. Yeah, I think I just did. You can get it there in the chat and share with your community members. Also, we usually have the open day, which we do every month, every last Thursday of every month. Here we would have industry experts, women that are doing big things in tech from all over the world, come on the call and speak to you on some of the challenges they face, how they've been able to navigate it, where they are currently, and also opportunities that are available for women in STEM. We do this every last Thursday of the month. Again, this is only for the ladies in the house. For the men in the house, you can reach out to your wife, your daughters, your sisters, your family members, community members, and they can join us. We have one coming up this coming Thursday, 25th of September at 4 p.m. If you check on our Instagram as well, you'll get more information about that then. And also, the fellowship is currently ongoing. For fellow, now we have the Women Textiles Fellow for the year 2025/2026. They are currently in class, they've been taking their classes, and the fellowship is a 1-year program. So next year, we are going to run another call for application for Women Textiles Fellowship 2026/2027. Right? So that will be all from me. If you have any questions for me, please go ahead and ask, and I'll try my best to answer. Okay, I can't seem to find any question.
Hello?
That way. Yes,
I have a
please go
question.
ahead.
Sorry,
Yes.
sorry. My name is Malakai.
Okay.
I wasn't getting. It wasn't clear. When you were speaking, I think I was having problem with my network. I can see you
Okay.
drop a link for a form. This form, is it for those who want to enroll for the boot camp?
Yes, this is for bootcamp.
Okay. So I can share it to people who are interested, right?
Yes, you can share it to women that are interested. Yes.
Okay. All right.
All
Thank
right.
you.
Thank you. Do we have any other question? All right. I think that is all. Once again, thank you very much for joining our 2 days masterclass, and enjoy the rest of your weekend. Bye.